Hi, I'm Andrea. I'm a software engineer here at Trilitech since 1 year and some months. I am part of the core development team. I'm leading this project on data availability committees, which are data scalability solution for the Tezos blockchain. But today I'm going to talk about something more basic, which is how does the Tezos blockchain work high level. But let me try to describe a little bit more how does basically a blockchain works. At the core of a blockchain user, we have a peer-to-peer network. Imagine that people want to submit transactions. Then they will have these transactions. First, they will sign them, like to certify that they are the ones making the transaction. And there are cryptographic protocols to do this. But once these transactions have been signed, like they can send to a node that participates in the Tezos network. And this node is responsible to broadcast it to other nodes using the peer-to-peer network. There are some entities in the blockchain which are called bakers or validators that are responsible to collect these transactions, basically execute them, or basically compute what is the final state of the blockchain given this block of transactions that they choose. They will also try to seek consensus, to reach consensus with other nodes, to say, hey, actually, there are these transactions, they have happened. We want to finalize them in the blockchain. So bakers, like they take rounds in reality, like one will go next, like one baker will go next and will say, okay, it's my turn to try to validate transactions. It will select transactions, it will place them in a block, it will broadcast this block to other validators or bakers that will say, yeah, I'm happy with that, so we can go through. If consensus is reached, which means that 2/3 of the bakers that are participating in securing the network, they say, yeah, this block can go ahead. Like the block receives a signature basically of these bakers, and they say, yeah, the block can go ahead, and it gets broadcast again to all the nodes in the Tezos network. Then these nodes will receive the block and they say, okay, now there are these transactions in this block that have happened. Like what is the final state, like updating balances or executing smart contracts, etc. Like they perform all these operations and that's it. The cycle keeps going, like there will be new transactions, they will be validated in a new block. That's it. Basically, now this is a very high level, like there are a lot of things that need to be ensured in a blockchain. So the first thing, like we already mentioned, that transactions need to be signed cryptographically. So basically all users have an account or more than one account in many cases. Like the account is basically a set of cryptographic keys. We use private key, public key cryptography. So the idea is that you can generate offline without the need of the network. You can generate offline your keys, and you have a private key which you should never give away. You should never communicate it to anybody else. Like you should keep it secure. Usually there is a set of 12 or 24 words that are associated with the keys. Like write them down, store them somewhere. Do not show them to anyone. It's very important. The public key instead is something that is public. You can give it to everybody. And in fact, the first thing that happens in Tezos when you perform the first transaction, there is an implicit operation that happens, which is called the reveal public key. Nodes need to be able to verify that you are actually the one signing the transaction, and they cannot do it if they don't have the public key. So the first operation of an account is actually revealing its public key. So you sign your transaction with your private key. The public key is included in some block as your first operation to say, reveal my public key to the world, so everybody can verify my transactions. You want to do a transfer of or execute a smart contract. You prepare the transaction, you sign it with your private key, you send it across the network. The second bit that is important is how do you secure the state of the ledger? Like we said, it's a blockchain, but we work like the network is decentralized, and we need to account for the fact that there might be actors that are malicious. So they will try to change the state of a block because they might want to say, hey, actually, you know what? All funds belong to me. It could be like you could try to inject a new block in the blockchain that says, oh, actually all funds belong to me. And that's why there is the consensus mechanism. Basically, when you want to do that, you need to create a new block where basically create new funds, like you mint new Tezos that say, hey, these are my funds now. But you need to reach consensus. Other people need to validate. Basically, the blockchain in general, like since the times of Bitcoin in reality, each block as a hash of the predecessor block. So which basically means like that you cannot go and insert a block in between. Like you can only insert it at the end of the chain, or at least it is very difficult to place a block in midway, because each block contains the hash of the predecessor block, which is a fingerprint, is used to attest actually the contents of the previous block. The state of the ledger is also distributed across all or many of the nodes participating in the network, which means that all the nodes will keep a copy of the blocks. Well, not all the nodes, but many nodes. Like we have nodes running in different modes of operation. But archival nodes, for example, in Tezos, yes, they store a copy of the whole blockchain since the beginning of the blockchain itself. So this is 3 million blocks, and a block is usually 500 kilobytes. So I don't know if it was 500 kilobytes in the beginning, but right now it's 500 kilobytes at most. It takes a bit of space to store the whole blockchain. Some other nodes that will just download new blocks and keep applying them. In the end, they only care about what the final state of the ledger is. They don't care about all the transactions that an account has performed. And they just care about their final balance, for example. Tezos is one of the first proof-of-stake networks. I'll take this a little bit from far. Originally, Bitcoin was proof of work. You have miners, you don't have bakers in there. But if you want to validate a new block, without going into particulars, like the more computational resources you use, then the more you will get a right to mine a new block, and you will get rewards for it. For Tezos, it's different. We have proof of stake, which means like that the more stake you have in the network, the more you will be given rights to bake a new block. Bakers take rounds, so initially when you start the process of baking a block, there is going to be a baker and only one that says it's your turn. You have 15 seconds to produce a block, send it across the network, get votes from other bakers, and collect the signature that 2/3 of the bakers actually validated the block. That's it. So if you don't manage to do it with in these 15 seconds, then there is going to be another round where there is going to be another baker. And it's his time. Basically, the sequence of bakers, they have been fixed time before by the blockchain itself, but says it's going to be the turn of another baker. Now it's your turn to bake, because we don't know why we didn't manage to get the proposal done in 15 seconds. It might be because the baker is offline. It might be because there are network issues. We really don't know. But now you have 30 seconds. So we are trying to be more secure. So 30 seconds is your turn. Go for it. And for example, I think that there was a scenario which was very unlikely on the 1st of January, also very unfortunate date, where the chain stopped for a couple of hours because consensus could not be reached. There has been a full report of the incident online, but in reality there was no incident. Like the chain behaved exactly how it was supposed to behave. It was just a combination that it was not possible to reach consensus for a couple of hours. So Tezos is proof of stake. It is a liquid proof of stake, in the sense like if you want to bake blocks, if you want to get the right of baking blocks, you need at least 6,000 tests. Many websites report 8,000 tests, but that's an old value. We decreased it to 6,000 tests last year. In reality, you only need 600 tests, but basically what happens, like you need to lock a value, some test as a security deposit, and then you can actually leverage up to 10 times that value from other people. So other accounts that don't have enough tests, or maybe they just don't want to bake, they can delegate somebody else. Like let's say I have 1,000 tests and I don't have enough tests to actually be a baker. I cannot get the right by myself to bake a block. So I will delegate my 1,000 tests to some other node, to some baker. And those bakers will be able to use it to actually get more baking rights and also more voting rights for the government's mechanism. So basically say, okay, I have 6,000 tests, but I got this guy here that delegated 1,000 tests, so my baking power is actually now 7,000 tests, up to 10 times the value. Why should anybody participate in this mechanism? Well, first, because bakers, they get rewarded for baking a block and also for endorsing blocks that are voted by other people. But The main idea is that, yeah, you bake a block, you get, I think now it's 5 Tez as a reward. And those 5 Tez, that's good. They are minted by the network, so they are new Tez that get minted. It's up to the baker to decide. Usually, what they will do, they will keep a small fee for themselves, which can be 5 or 10%, but they will distribute the reward according to the amount of Tez that delegates have delegated to the baker. Let's say there is this baker that has locked a value of 6,000 Tez plus my 1,000 Tez for delegation. It means that every time that the baker will bake a block and will get the 5 Tez of reward, 1/7 of that reward will go minus a fee of 10% or 5%. This is decided by the baker. The baker, if it is dishonest, they might decide to just keep all the reward for themselves. The baker will just send back an amount proportionate to the sum delegated. The benefit of liquid proof of stake is that, yes, bakers need to freeze or to lock an amount of Tez to participate in the baking process, but delegates do not. So I have delegated 1,000 Tez. First, they are not at risk. Like only the baker's value locked is at risk. In the case that, for example, the only case in which where in Tezos you can be slashed and you can lose, I think it's all your security deposit. It's when you do double baking, so you try to bake the same block twice. There is somebody else can accuse you, say no, you try to double bake a block, and here's the evidence, and then you will lose all your security deposit, if I am not mistaken. But me, as a delegate, I will just say like, no. I mean, yes, I delegated to this guy, but my delegated amount is not at risk. So probably I will just not be rewarded, but that's the most that can happen. That's why it's liquid proof of stake, because I can just keep using my Tez as if nothing happened. Like I can still, I mean, I've delegated, but I can still buy NFTs, transfer Tez, like that's how it works. So I will say this gives a panoramic of the Tezos blockchain. So basically that we have covered quite a lot of topics. Like this was quite high level, but I really thank you for listening. Like from my side, it's been really fun. I hope it's been really fun for you, and I hope that gets also the people like interested in Tezos, because truly I do believe it's a very cool blockchain, and I hope that many people will start to see it for it. So thank you very much.